they will come in like 1 2 minutes maybe. Some of them, yeah. Do you want me to introduce you, or you're going to do it first?
No, don't need it.
Okay.
I'm a simple man.
Okay.
Give him 1 minute and yeah. I'm gonna end before time anyway.
That's good. This is the last session for today.
Yeah, everyone wants to go home.
Yeah, but there is some surprise.
Yeah, I know, in 5:15.
Yeah, so I don't think many people would come home.
Mm.
They're expecting some food.
Will it be?
I don't think so, but everyone expects. And associate are very hungry people.
Ah, really?
Yeah.
Everyone is hungry.
Yeah, the developers are the most hungry.
Fair enough. Okay, so think we can?
Yeah, sure.
Okay. Okay, good afternoon, everyone. Let's just find the notes section. Oh. Just a second. Why don't I see the notes? Yes, now it's good. Okay, so good afternoon, everyone. My name is Tal Nisan, and I'm a team lead in the Rev Storage team. Been running Crode professionally for the last 22 years. Started my early days from assembly and Pascal throughout C, C++, and nowadays for the last decade or so, mostly in Java. Throughout those years of my experience, I've encountered a problem which almost in every big project I've contributed to, and I haven't found a proper name for it or a well-known name for it, so I've decided to refer to it as black boxes. So you probably ask yourself now, what are black boxes? Okay. Sorry, my presentation for some reason is not working with the computer. Okay, finally. Okay, so you know those areas in the code where everyone is afraid to touch, those modules or classes which whenever there's a need to introduce a change, no matter how small it is, everyone is against it. Over the course of my career, there were many, many occasions like that when I was told or overheard colleagues telling to other colleagues, no, don't touch it. It's a very core part of the project. It's working well, and if you touch it, it will most likely break and bring a lot of regressions along with it. Or on the other hand, the more like it's John Doe's model. He wrote it, and only John knows how it works, and he's the only one that is allowed to touch it. And obviously, when you reach out to this same Mr. John, and you tell him like, okay, so we have to introduce this and that. The PM told us that we have to introduce like, Not gonna happen. Leave it to me. So either there are two reasons, or the code is written so messy that it's almost impossible to understand how the hell is it doing what it's supposed to do. Sometimes even what is it supposed to do. And I guess it happened to all of you. Yeah, I can see a lot of nods, so probably yes. So some people are asking if are those black boxes really that toxic? They will see no problem with that, and they will tell you, like, Mr. John Doe is in charge of this model. He does it well. Why let other people touch it? This extremely sensitive part where John is doing perfectly fine work and raising the risk of introducing some sort of a regression. Or on this part of the code is the backbone of our system. It works as it should. And some people have the rule, if it's working, don't touch it. And especially we're adding new logic with little to none benefit that might cause problems because of that. So in Hebrew, we have a word for those explanations. Yes. But why are there excuses? So first reason, because the code rots. End of the day, a code that remains stale might be working as it did before. That's right. But it prevents the code from evolving, getting refactored logic-wise and performance-wise, and adopting new technologies. Also, more people usually, not always, but usually means better code. More people maintaining the code tends to bring more ideas, more people to back up one another in their work, and the benefit of people being able to code review one another, introduce problems early before they reach inside the code. And what we call or refer to as the bus factor, which you get by having a single or a small group of people being the sole maintainers of a certain model in the project, most likely to create a bottleneck if you're lucky, or even worse if the person are becoming unavailable for some reason. Or put it more bluntly, what happens if this person is getting hit by a bus? Hence, the bus factor. So, how can we change that? So, first of all, we'll take some steps from the Alcoholics Anonymous playbook, accept that you have a problem. Second, take a stand and decide that you are going to address this problem. And third, get all the relevant people on the team on board for that. But how? So some people say, well, one person said it, but it was adopted later by other people. Rome wasn't built in one day. So we have to accept the fact that it is quite scary to touch those core areas. There will be no magic solution that can make it happen overnight, unless, I don't know, lots of caffeine and a big team, but still I doubt it. So what I'm about to show you is a series of steps that will ease up the transition and hopefully will leave you with a more readable and maintainable code. So step number one will be grow a pair. So a little anecdote is that I had a bit of a blunter picture here, but my manager forbade me from using it, so this is what we've got instead. He's up there. You can talk to him after the presentation. So yes, you will need to grow a pair, metaphorically. This thing says courage, and yes, code can break and introduce regressions. They may arise, but in order to build something better, sometimes you have to break a few walls on the way. Now, once you've got that covered, it's time to start that real work, make the code readable and maintainable. That's the first step you have to do anyway. So, one of the things you should probably start with is changing unclear class names to names that actually describe the general purpose of the class. Here's a bad example of a class name. And after changing it, use a name that gives a better idea of what this class is up to. And along that, we have the variable names, which you should probably change to names that actually mean something to the reader and describe what the variable is used for. That's a bad example of variable naming. Doesn't really tell you anything, is it? No, I thought so. Quite a better example that can help and tell you more about the purpose of those variables. Method names, you should change them probably to describe what the method is actually doing. And not that good of a name, right? The best, yeah. Okay, so the next method will probably be execute2, right? I'm good with that. Yeah, but it's a bit of a better name, I think at least. After that, we get a name which is a bit more explanatory and actually tells the reader what it does. And another thing, always important, documentation. Documentation, documentation. You cannot stress that enough. Okay, document everything. The fact that you understand now what you did doesn't mean your predecessors touching the code will. And quite likely that after a few years, not even you will understand what you did there. Document everything. Okay, so here's a bit of a better example. Yeah. For that matter, it's a Java doc, but I've heard you have those also in Python and in other languages, so you should probably use it. Okay, so breaking big endless methods. Big endless methods are very unreadable, very hard to maintain. Logic should most likely be split into smaller methods, each dedicated to perform the smallest logical task possible. In this bad example, we see a method with many lines. I wrote 1,000, but I meant a lot of lines. There is no clear flow of what's going on in the method. You have to dive really inside the method into all the lines and actually see what is going on there. Kind of pointless. It's a bit of a better example. Breaking it to a few smaller methods, you get a clear view of the logical flow of what the method is actually doing on first sight. And testing. So now that we understand what the code actually does after the nice legacy that Mr. Doe left us, we know how to test it, hopefully. We broke it into small logical units, units we can usually test. And once we add the test, we reduce the risk of breaking the old functionality when we add new functionality and new logic inside it. And if we reach this point, try not to stop in unit tests. Sometimes you cannot easily write unit tests as well. So in that case, and even in general, always try to introduce component tests and system tests if it's applicable. And in conclusion, we've covered a bunch of things here, but what I really like you to take from here is a few things. First of all, where you stand, I mean, you all come from different projects, different places, different languages. Try to understand if your project actually suffers from the existence of black boxes in the project. And if so, find a willingness and develop the courage needed to finally break this endless circle. And use the mentioned steps as a guideline and also others to open those black boxes finally, and for everyone's benefit. Yeah. And questions? Not even one? Good?
So I have a question.
Yes.
What to do when John Doe is really like comfortable being the sole maintainer? Like he doesn't really want that.
So the question is what to do if John Doe is comfortable of being the only maintainer. First of all, I'm sure, because those John Does are always comfortable in being the sole maintainers. Always. It's job security, they're the bosses, they know everything, you don't know nothing. It's quite of a problem. It's quite of a problem. I'd say that this is more of an HR question rather than. First of all, yes. If you have a relative who's a bus driver, you can introduce the bus factor, but don't. Is it recorded? Forget about it. In that case, it's more of an HR problem. But if the team is on board for that, if your manager is on board for that, and he should be on board for that, because it's very easy, because John Doe can fix the problem in 1 hour, which will take you 2 days, okay? But John Doe might not be there forever, and various reasons, not necessarily your uncle who's a bus driver, but various problems. So your manager should probably be up to that. And even if, once the whole team and the manager is up for that, and John Doe finally, hopefully, is accepting that fact, he will take half a day to explain to you how to do it maybe, or you will spend the time and effort doing the same. But step by step, you're getting closer to be that John Doe. Just try to be nicer. So, no magic solutions in that, but the team should be on board, your manager should be on board, and John Doe should be. Let's stop the grip on his, job security. That's my idea about it. Yeah, mostly it's like that. Yeah. But it's also a lesson for John Doe's, leave your grip. So, it's nice to be the number one person that handles this and that, but it's best for you as well as John Doe's. Not that I'm saying that any of you are, but. Questions? Well, first of all, refactor all the time. I know at least someone like me in this room, for using some planter images later, and we refactor all the time. We have a saying that there's nothing that a programmer hates more than a code he himself wrote half a year before. The black boxes of today are the most genuine and best thing that happened to you half a year ago, The code evolves, we evolve as people, as programmers, So always be on the refactor side. This is what you should do probably. Always strive to get it better and better and better. If you fear about why refactor or why change this from this technology to this technology, fear will get you nowhere. You will still stay in a project in Java 4 and you know what I mean, running on RHEL 3.5. So, anyone else? So to summarize the question, if we have a big project, is it better if everyone is touching everything, or?
Because my experience is if everybody does everything.
Yeah, no.
Nobody does it.
Exactly, or some people focusing on their. Well, it's a good question, but as you say, you can be the jack of all trades. Not sure if it's the best, as opposed to being an ace in your specific area. But dividing projects into sub-projects with specific people handling this area is completely fine. But the problem comes when it's usually a very limited number of people touching this specific, while the others have the knowledge and maybe not the knowledge, but the capability at some point to touch this area, and they're forbidden from doing so for that reason.
Because it's usually the problem that John Doe doesn't want anyone else to touch his code, but the problem is that there's nobody else who's able, like, there are limited resources.
Yeah, of course, ability and capacity is not the scope of what capacity is capacity. You cannot control that. If you're 4 programmers with many projects, 40 with many, but capacity is capacity, you know, this is something else. But I'm talking about specifically projects where you are able, or at least you are able to reach and actually do it, but you are forbidden from doing so. So this is what my capacity. I think I have 1 minute left.
Yeah, 1, 2 minutes, so one last
minute,
question.
One last question, if we have. Good,
So thank you, Tal.
Yeah, thank you. Okay. No, I had to click here, that's the problem. And before it was okay. That's all I had to do.
Okay.
Well, now you will be here tomorrow.
Yeah, but actually everyone is using different programs, different cases, different platform, different systems. One guy came through the Windows.
No.
Everyone was like, oh my.
Jada.
Yeah, that was very funny. And some guys they have that's fine, you know, but Windows.
Knife in the back. Now we can go to the surprise.
Yeah, there will be some surprise.
And then get drunk.
Yeah, tomorrow.
No, today.
Yeah, you today and I today, but somewhere else. And tomorrow there is the party.
All right. There is one. I finished my Very nasty.